Part 7 of the NotesQuest has been split into two videos. The first video, which you're watching now, will talk about speed and acceleration, and in particular the two equations relating to that. The second part, video 2, which you'll see after this one, looks at the shapes and motion graphs. Let's start by looking at what speed is. Now, to know what speed is, we need to know what distance is and what time is. We already have an idea of what distance is, and it can be measured using things like a ruler, a tape measure, and the units for distance are meters often. Now, they could be in kilometers as well. Remember, kilometer or kilometer is 1,000 meters. It could be in millimeters, but the standard unit where we can is meters. You might also know about miles as well. For the symbol for distance, at this level, we are just going to use D as the symbol for distance. Time, we can measure that using a stopwatch. Sometimes they might ask you to name the apparatus where you just use a stopwatch like we've done in class. The symbol for time is T. And the units, again, ideally would be seconds, but you might also use minutes or hours. But if you can, convert them into seconds because that's the standard unit for this. So here we have two important concepts for this, and you need to know how we can measure them, which is here and here. The symbols for them, which is here, and the units, which is here and here. Let's now have a look how that relates to speed. Speed. Now the symbol we use for speed, rather confusingly, is V. The reason being that speed is related to velocity, which we'll see in later years. It's slightly different, but we'll learn about that in later years. So use the symbol V for speed. If you're unsure, just write it in words, unless it specifically asks for the symbol. And the speed is defined as the amount of distance covered per unit time. Now you could also say per second, but per unit time just sounds more fancy. So that's the definition. And as you can suspect from this, if it's the amount of distance covered per unit time, we can actually turn this into an equation. So the speed is the amount of distance covered, so it's going to have distance in the equation, per unit time. So that per means divided by. So we get this equation here, which is speed equals distance over time. You need to learn this one. In symbols, I'll do that in red below. We have V for speed, D for distance, and T for time. Remember, you can rearrange this. If we want D, we can take the T over to the other side. Now, at the moment, it's divided by, so if we times both sides by T, we end up with V times T on the left-hand side, and we just have D on the other side because the two T's will cancel. So that gives us how we can find distance. And now if we wanted to get time by itself, we can see that at the moment they're times together, so we need to do the opposite. We divide both sides by velocity to have time by itself. And that will give us time equals distance divided by, sorry, I said velocity, I mean speed. Time equals distance divided by speed. So there's the two equations there. There is a triangle. Remember, it's best you learn how to rearrange it, but if you want the triangle, V times T and D goes up the top. So that's speed, and that's how you calculate it. Let's now have a look at an example. Let's use Usain Bolt. Now he's run 100 meters, as we know. It took him 9.58 seconds, if I remember correctly. So what is his speed? Why don't you pause the video and have a go at that? So hopefully the first thing you did was realize that this here is a distance, this here is a time. As always, you start by writing the equation, either in words or in symbols. Sorry, Miss Garner's made a mistake there. There it is. Now we put in our numbers. We know he travels 100 meters in 9.58 seconds. You then type that into your calculator, and you get 10.4. And now we need to think about the units for speed, which we haven't actually mentioned yet. What are the units? Well, if you think about it, this is the number of meters, and this is the number of seconds. So it's just going to be the meters per second are the units. Other units you might have heard of are kilometers per hour for your car, unless you're in America or the UK where they'll use miles per hour. But those are not very useful in physics. We ideally want meters per second. If the time was given to us in minutes, remember you can convert minutes to seconds by timesing the minutes by 60. 1 minute is 60 seconds. So what does speed tell you? Well, it just tells you the distance it travels per unit time. So in this case, we have a car here going at 10 meters per second. And you can see that this is telling us that after every second, it travels 10 meters. That's what it says up here. So after 1 second, it's gone 10 meters. It's another second later, it will go another 10 meters, meaning the total distance travelled from the start would be 20 meters. And of course, you could work that out using the equation. Distance is the speed times the time. We do 10 meters per second, and we do it for 2 seconds. We get a distance travelled of 20 meters, which agrees with what we can see on this diagram. So that's the idea of speed. Now this car here is not accelerating. That means it's not getting faster or decelerating, which would mean it would be going slower. So what does that mean? Well, that's the other idea you need to know for this in this video, and that's acceleration, which we can see with this image here. This car has an acceleration which has the symbol A, makes sense, this is physics, of 2 meters per second squared. Now this looks like a weird unit. Notice how the only difference between speed and acceleration is this squared here. So watch out for that. It's meters per second squared. So that's the units of acceleration. You might want to make a note of that. What does this tell us? Well, it's telling us that it's going 2 meters per second faster every second. That's where the unit meters per second squared comes from, because it's meters per second. Or you could write it like that, but that's messy. So we just write it like that. You don't need to know that, but it explains acceleration nicely. This 2 meters per second tells us that car is getting faster by 2 meters per second every second. So at the start, t equals 0 seconds. Here's the start. You can see it's going at a speed of 0 meters per second. 1 second later, we know that it's going to accelerate it by 2 meters per second every second, so we know it's going to be going at 2 meters per second. Another second later, it's going to be 2 meters per second faster, so it's now going 4 meters per second. Another second later, 6 meters per second. So this, you can see how the distance travelled each time is larger because it's going faster each time. So this is accelerating at 2 meters per second. That's often how they measure cars. We say the acceleration of this Bugatti is whatever it is. You know, it can go up to 100 kilometers per hour in 10 seconds. Probably a bit faster than that. So, what is the equation for acceleration? Well, acceleration, which has the symbol A, is equal to the change in velocity. And for year 9, you can just think of that as speed, although it is slightly different, and we'll see that in year 10, divided by the time taken. Now, we can represent that word change in using a symbol. So let's write this now as symbols. Acceleration is the symbol A. And to represent change in, we use the Greek letter delta, which is just a triangle. That means there's a change in. And because it's velocity, remember we're saying it's the same as speed, so it has the symbol V, divided by the time taken, which we know is t. You can think of this change in velocity as the final velocity, so whatever it is at the end, minus the initial velocity. So let's have some fun with this equation now, looking at this example over here. Forget about all the writing I've got on it, and let's look at what we know. So we can see that at the end, after 6 seconds, it's travelling at 6 meters per second. Sorry, 3 seconds, it's travelling at 6 meters per second. At 0, it was stationary. Its velocity was 0. So how can we use that in this equation? Well, we know that the final velocity equals 6 meters per second. The initial or starting velocity or speed was 0 because it was stationary. So we know that the change in velocity, 6 minus 0, which is just 6. And we know it did that in 3 seconds, as we can see up here. So let's now put those numbers into our equation. A equals change in velocity, which is 6, divided by the time taken, which is 3. And there we have it. Bob's your auntie. You can see that you get 2 meters per second squared as the acceleration. And that's what we said at the start. So that's very useful because that tells us, well, we know how fast it could be going in 10 seconds time because we could use that equation. How do we rearrange that equation? Well, again, here's a triangle, although you do not, well, it's best you learn how to rearrange it, but I'm going to give it to you anyway. Here's the triangle, change of velocity at the top, acceleration times time. To rearrange it, let's see how you do that. So at the moment, we've got A equals delta V over T. Let's say we want to get delta V by itself. We times both sides by T to get the T up here. So you end up with T times A equals delta V. Because remember, if we times this side by T, these two T's are going to cancel. So there's our equation rearranged to find the change in velocity. And now to find, let's say we want to find the time, we can now see we need to just divide both sides by A, because we want the T by itself, and at the moment this bad boy's in the way. It's T times A divided by A, because we have to do it to both sides, they will cancel, just giving us T. And then we need to do the same to this side, so it'll be delta V over T. So that gives us our second equation. So we need to know both of those, that one there and that one there. But if you just learn how to rearrange them and just learn this equation, this is the most important one, you've got to learn that. And you've got to make sure you include the word change in or include the triangle here. The next quest asks you to come up with your own questions. So just think about an object. It could be you running, or it could be a car, and just come up with some questions relating to that. You could say a car has an initial velocity of 0 meters per second. After 10 seconds, it has a velocity or speed of, let's say, 30 meters per second. What is the acceleration? I want you to come up with your own one. So just use your imagination and then make sure you show how you get the answer. So write the equation, put the numbers in. Change in velocity in this case is 30 minus 0, divided by the time taken, which is 10. And that will tell you that it's accelerating at 3 meters per second squared. So make sure you show how you get your answer in your NotesQuest. I hope you found this useful. Remember, the second part of the video, which is 10 minutes long, goes over motion graph shapes. Thanks for watching.